Hi. So I'm going to talk about how to find the inverse of a matrix. With the best definition or the formal definition using determinants and cofactors. Okay. So before that, let's go through what we mean by the matrix of cofactors from a given matrix. So if you have a matrix A, right? Assuming you've been given a matrix A, then a matrix of cofactors is being given by the cofactors you get, put them together in a matrix form, and that is a matrix of cofactors given from or that we can get from a given matrix. And the adjoint of a matrix, okay, is the transpose of the cofactor matrix, and then the inverse of A is 1 over determinant of A times the adjoint of A. Now at this moment I feel we are so ready to go through all these to find the inverse of a matrix. And what I'm going to do is when you get to the cofactor part, I'm not going to go through the whole process again because I have a lesson on that. I'm going to leave it in the description section so that you'll be able to get to that, and then try to watch it, or if you understand the cofactor process, then that is okay, right? So an example is this: I have A given as this matrix. You have 3, 2, -1, 1, 6, 3, 2, -4, 0. And then we want to find the cofactor matrix. So by cofactor process, C11 will be given by 12. And I'm going to just do a C11 for you. I said I wasn't going to do that, but the C11 is trying to be on the 1, 1 entry of A. Okay, so C11 will be equal to -1 to the power the sum of these two numbers. Okay, C11, I is 1, J is 1, so add it like that. 1 plus 1, and times the determinant of this matrix here. So you cancel the values in the same column with 3, and then the values in the same row with 3, and the remaining matrix that you have here, you take the determinant of that. Okay, so we're going to take the determinant of 6, the matrix 6, 3, -4, 0. And the determinant of a 2 by 2 matrix from our lesson, so -1 to the power 2 will give me 1 time. The determinant of a 2 by 2 matrix from our lesson is 6 times 0, which is 0, minus -12. And that will give us 12. So that is C11. You're going to go through all these entries you have here. So C22 will be based on this, C12, sorry. That is the 1, 2 entry of A, and then C13 and the rest like that. Okay, so if you do this properly, you're going to get C12 to be 6, C13 to be -16, C21 to be 4, C22 to be 2, C23 to be 16, C31 should be 12, C32 should be -10, and then this guy is 16. Alright, so you have them like that. Let me put a comma in them. So you have all these. Then a matrix of cofactors from this matrix given A is given as C11 here, which is 12. So you put them in a matrix form, C12 -16, and this guy is going to give me 4, 2, 16, 12, -10, 16 again. Alright, so that is my matrix of cofactors from this given matrix A. Now if I'm being asked to find the adjoint of this matrix A, the same matrix A, then I have to get the cofactor matrix like I have here, and I find the transpose of this cofactor matrix. And the transpose of this cofactor matrix, which is the adjoint of A, is given by transposing your matrix. And if you transpose it properly, you're going to get 12, 4, 12 again, 6, 2, -16, -10, -16, 16, 16. So what the transpose does is it picks all these columns, write it as a row. So I have 12, 4, 12, right? So all these columns like that, 12, 4, 12 as a row, and you pick this second column, write it as the next row, pick the third column, write it as the last row. So all these things, I have lessons on them. You can check them out in my linear algebra tutorial videos or playlist. And so if you use any of the methods that we've learned so far to find the determinant of a matrix, then the determinant of the given matrix A is 64, and that one too I have a lesson on that. So the inverse of A will be given by 1 over the determinant, which is 64, times the adjoint matrix, which is 12, 4, 12, 6, 2, negative 10, negative 16, 16 times, and then 16 again. I mean, so that is the whole process about using cofactor matrices to find the inverse. So you can try to use other approach like the Gaussian elimination method, that Gauss-Jordan elimination method, to find the inverse, and you're going to get the same thing as this. One thing this does is that this method actually just straight away use the determinant process to find the inverse, because the cofactor matrices will be using determinant, and then the adjoint is just a transpose. Okay, so yeah, I'm gonna start a new set of lessons on in linear algebra. So thank you for staying through with me on matrices and their properties, determinant, the operations we can do on them. See you in our next lesson.